Welcome back. In this teaching video, I'm looking at 4.2 roots of a cubic equation. 4.2 represents chapter 4, section 2 of the core pure 1 textbook. Let's have a look at the key facts of this section. Let x equal alpha, x equal beta, and x equal gamma be the roots of the cubic equation. Ax cubed plus bx squared plus cx plus d equal to 0, where a, b, c, and d are constants and a is not equal to 0. Ladies and gents, the cubic ax cubed plus bx squared plus cx plus d can be factorized into a outside the bracket, and inside the bracket we've got this cubic. Now this cubic over here can be factorized into three brackets. We have x minus alpha, x minus beta, and x minus gamma. Why? Because x equal alpha, x equal beta, and x equal gamma are the roots of this cubic equation. We can then expand these two brackets and we get this quadratic. We then expand this linear with this quadratic to give us this cubic. The next step is to expand the a with this cubic to give us this cubic, and then we can collect like terms and factorize and get the following cubic. Ladies and gents, we know that this cubic is equivalent to this cubic, hence I've written that this cubic over here is equivalent to this cubic. We are now going to compare coefficients. So if I compare the coefficient of x squared on both sides, I can see that minus a in bracket alpha plus beta plus gamma has to equal b, which is written over here. So if I make alpha plus beta plus gamma the subject, I get that alpha plus beta plus gamma is equal to minus b over a. Next up, comparing the coefficients of x. So the coefficient of x over here is c, and the coefficient of x over here is a in bracket alpha beta plus beta gamma plus alpha gamma. So we must have that a in bracket alpha beta plus beta gamma plus alpha gamma has to equal to c, which is written over here. So if I make alpha beta plus beta gamma plus alpha gamma the subject, I get that alpha beta plus beta gamma plus alpha gamma is equal to c over a. Now we are going to compare the constant term. So over here the constant term is d, and over here the constant term is minus a alpha beta gamma. So we must have that minus a alpha beta gamma has to equal to d, which is written here. So if I make alpha beta gamma the subject, I get that alpha beta gamma is equal to minus d over a. Solid. Right, now for this cubic over here we will have three scenarios. Scenario number 1, we can have 3 distinct real roots, or scenario number 2, we can have 1 real root and 1 repeated root, or finally scenario number 3, we have 1 real root and 2 complex roots. Key fact, the 2 complex roots occur as a conjugate pair. Juice, nice. So that there is the key facts of 4.2 roots of a cubic equation. I'll be implementing these key facts within exam style questions. Here is the first exam style question. The cubic equation 16x cubed minus kx squared plus 1 equal to 0 has roots alpha, beta, and gamma. Part A, write down the value of alpha beta plus beta gamma plus alpha gamma and alpha beta gamma. Okay, so let's have a look at the solution to part A. So we want to work out the value of alpha beta plus beta gamma plus alpha gamma. So from our key fact, this is given by c over a. From the cubic, we can see that a, which is the coefficient of x cubed, is 16, and c, which is the coefficient of x, is 0. So the alpha beta plus beta gamma plus alpha gamma is equal to 0 over 16. Hence the value of alpha beta plus beta gamma plus alpha gamma is just 0. Now I'm going to work out the value of alpha beta gamma. So alpha, beta, gamma, according to our key fact, is given by minus d over a. So I've got minus d over a. So for our given cubic, a is equal to 16. D, the constant term, is equal to 1. So the value of alpha, beta, gamma is given by minus 1 over 16. This completes part A of the exam style question. Moving on to part B, part 1 of the exam style question. Given that alpha is equal to beta, find the roots of the equation. So we have part B, part 1. Alpha equal beta, this implies that I can replace the beta in this equation with alpha. So I've got alpha squared plus alpha gamma is equal to 0. Simplify this equation. This gives me alpha squared plus 2 alpha gamma is equal to 0. Equation number 1. Now I'm going to replace the beta in this equation with alpha. So this gives me alpha squared gamma is equal to minus 1 over 16. I can make gamma the subject. So I've got gamma is equal to minus 1 over 16 alpha squared, equation 2. I need to solve these simultaneous equations to work out alpha and gamma. I'm going to substitute equation 2 into equation 1. So sub 2 into 1. I've got alpha squared plus 2 alpha multiplied by minus 1 over 16 alpha squared equals 0. So this alpha will cancel one of the alphas in the denominator, and I've got minus 2 over 16 is basically minus 1 over 8. So all in all, I've got alpha squared minus 1 over 8 alpha is equal to 0. I can multiply the entire equation by 8 alpha. This gives me 8 alpha cubed minus 1 is equal 0. So alpha cubed has to equal 1 over 8. Hence alpha is equal cube root of 1 over 8. So the cube root of 1 over 8 is just 1 over 2. Now we know that alpha is equal beta. So your beta is going to equal 1 over 2. Now to work out the gamma, I'm going to substitute alpha equal 1 over 2 back into equation 2. So I've got minus 1 over 16 multiplied by 1 over 2 in bracket squared. So this gives me minus a quarter. Hence, the roots of the cubic equation are alpha equal a half, beta equal a half, and gamma equal minus 1 over 4. This completes part B, part 1 of the exam style question. Let's have a look at part B, part 2 of the exam style question. Now for part A and part B, part 1, we have utilized these two key facts here. For part B, part 2, we're going to have to utilize this key fact over here. Right, so part B, part 2. We know that alpha plus beta plus gamma is equal to minus b over a. For our given cubic, a is equal to 16 and b is equal to minus k. So I've got alpha, which is a half, plus beta, which is also a half, plus gamma, which is minus a quarter, has to equal minus b, so that would be minus k, which is just k, over a, which is 16. So I've got 3 over 4 is equal to k over 16, hence k is equal to 12. This completes the first exam style question. Here is the second exam style question. The cubic equation 2x cubed minus 10x squared plus 8x minus k equal to 0 has a root at x equal 3 minus I. Part A, find the other two roots of the equation. Let's have a look at the solution to part A. Let alpha be the first root. Let beta be the second root. Let gamma be the third root. Now I'm going to call the alpha 3 minus I. Now if there are complex roots, and this is your first complex root, the other complex root has to be a conjugate of this complex root. So I'm going to say beta is 3 plus I. Now I want to work out gamma. I'm not sure of what gamma is. Okay, let's go back to our key fact. We know that alpha plus beta plus gamma is equal to minus b over a. So alpha plus beta plus gamma is equal to minus b over a. For our given cubic, a is equal to, b is equal minus 10. So I've got alpha plus beta plus gamma has to equal 10 over 2, which is 5. Remember, we've got a negative there, so minus 10 is just 10, so 10 over 2, which is 5. Replace the alpha with 3 minus I, the beta with 3 plus I, and leave the gamma as it is, equal 5. Rearrange, work out gamma. So I've got 3 minus I plus 3 plus I plus gamma is equal to 5. Now minus I and plus I will cancel out. 3 plus 3 is 6, plus the gamma is equal to 5. Hence the gamma is equal to 5 take away 6, which is minus 1. Therefore, we can now conclude that the other two roots are x equal 3 plus I and x equal minus 1. This completes part A of the exam style question. Moving on to part B. Hence, find the value of k. So we are after the value of k. Now the k is associated to the d term, so if we go back to our key facts over here, which one has a d involved? It is this one over here. So we have that alpha, beta, gamma has to equal minus d over a. So for our given cubic, we know that a, the coefficient of x cubed, is 2, and we know that d, the constant term, is minus k. So I've got alpha, beta, gamma is equal to minus k, which is just k, over 2, the a value, which is 2. Okay, so now I can replace the alpha with 3 minus I, the beta with 3 plus I, and the gamma with minus 1, equal k over 2. So I can put the minus 1 at the front, and I've got a difference of 2 squares over here. That will become 9 minus I squared, equal k over 2. Now we know that I squared is equal minus 1. So 9 minus minus 1 is just 9 plus 1, which is 10. And then we've got a negative there. Hence we have minus 10 equal k over 2. Rearranging this gives me k equal to minus 20. This completes the second exam style question. Moving on to the third exam style question. Given that the roots of 8x cubed plus 12x squared minus cx plus d equal to 0 are alpha, alpha over 2 and alpha minus 4, find alpha, c and d. Let's have a look at the solution. Let alpha be the first root. Let beta be the second root. Let gamma be the third root. Now we're going to call alpha, just the alpha, that's the first root. We're going to call beta, alpha over 2, the second root. And we're going to call gamma, alpha minus 4, the third root. Now using this key fact over here, we know that alpha plus beta plus gamma has to equal minus b over a. So for our given cubic, a, the coefficient of x cubed, is 8. B, the coefficient of x, is 12. So we have that alpha plus the beta, which is alpha over 2, plus the gamma, which is alpha minus 4, has to equal minus 12 over 8, which becomes minus 3 over 2. Now alpha plus alpha over 2 plus alpha is 5 over 2 alpha minus 4 equal minus 3 over 2. Multiply the entire equation by 2. This gives me 5 alpha minus 8 equal minus 3. Okay, so 5 alpha is equal 5, hence alpha is equal 1. Now I need to work out the value of c and d. Now to work out c, we're going to use this key fact over here because there's a c involved in this formula. So I've got alpha beta plus beta gamma plus alpha gamma is equal to c over a. So for our given cubic, a is equal 8, c is the coefficient of the x term, which is minus c. Okay, so I've got alpha, the beta is basically alpha over 2 plus beta, which is alpha over 2, The gamma over here is alpha minus 4, and then I've got plus alpha, gamma is alpha minus 4. This must equal minus c over 8. So I've got these two multiplied together gives me a half alpha squared. I'm going to expand this bracket. This gives me plus a half alpha squared minus 2 alpha. Expand this bracket, plus alpha squared minus 4 alpha equal minus c over 8. A half alpha squared plus a half alpha squared is just alpha squared, plus alpha squared, that would be 2 alpha squared. So 2 alpha squared, cross this out, and then I've got minus 2 alpha minus 4 alpha, so that's minus 6 alpha, cross this out, equal to minus c over 8. Substitute alpha equal 1, so I've got 2 multiplied by 1 squared minus 6 multiplied by 1 is equal minus c over 8. So that there becomes 2, that becomes 6. So 2 minus 6, that is minus 4, equal minus c over 8. 8 multiplied by minus 4, minus 32 equal minus c, hence c is equal to 32. To work out the d value, we're going to have to use this key fact over here because there's a d involved here. So I've got alpha, beta, gamma is equal to minus d over a. So for our given cubic, a is equal 8. D, the constant term, is just d. So I've got alpha multiplied by beta, so beta is alpha over 2, multiplied by gamma, which is alpha minus 4, has to equal minus d over a, so that would be minus d over 8. So the a is 8. Multiply these two, I get a half alpha squared, and then I need to expand it with the alpha minus 4 equal minus d over 8. So I've got a half alpha cubed minus 2 alpha squared is equal minus d over 8. Substitute alpha equal 1 into here. That gives me a half minus 2, which is minus 3 over 2, equal to minus d over 8. So if I make d the subject, I get d equal 12. So all in all, I've got alpha equal 1, I've got c equal 32, and I've got d equal 12. This completes the third exam style question and this teaching video 4.2 roots of a cubic equation. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.